up a Piazza account for this class. Is there any, would you like me to set up Piazza for this class? Anybody? You would? Yeah? Okay, I'll set up Piazza. So send me an email about it. Would you, that'll remind me, and tomorrow I'll set it up. Okay, so I guess we'll get started. So this course has expectations that you are reasonably comfortable with both C# and C++. We're going to use both. It's entirely possible if you're, for example, taking object-oriented design this spring to do them as you know. That isn't a hard prerequisite, but we will be using both C# and C++. Not, you know, not the hard parts, but we will be. And then we'll be using some other stuff as we'll get into. So, the model of this course is, first of all, I want this, you know, my own model of this course is it's like a capstone course for the sequence of design courses I teach. It's, in my mind, it's the last course in the sequence, and it gives you an opportunity to work on some things you wouldn't have a chance to work on otherwise. You know, it's things you're interested in, and we just don't have any course content in that area or something like that. It gives you a chance to work collaboratively with other students in a class if you want to. But the content is intended to be, focuses on components, especially the beginning part of the course. And I like to see our projects involve cross-platform work or cross-technology work or distributed in some sense. And, you know, our conversation today, I think, will make that a little clearer. What does all that mean? But, and there are no exams in this course. There are 3 presentations. Everybody will make 3 presentations. So in a sense, those 3 presentations are oral exams. Okay. And I'll make it clear. So there's one individual project that maybe constitutes at most 20% of the course, and the rest of it is a set, you know, people are working on bigger final projects. Again, could be an individual effort, but it could be a collaborative effort. Either one is fine. I begin talking about, in this course, a little bit about Linux, and a lot about Microsoft's component object model technology. And the reason for that is that if you're going to develop on a Windows platform professionally, COM pervades that platform. It's everywhere. COM is a fairly old, awkward, aggravating component model, but what it does very, very well. COM is responsible for Bill Gates having a big fat wallet. It supports building large systems in parts and using interfaces in object factories so that we can change the implementation of a part without breaking the build for other parts. The .NET CLR is a COM object. Windows Shell is a COM object. Series of COM objects. Windows Diagnostics, COM objects. IIS has a whole bunch of stuff wrapped in .NET wrappers, but they're COM objects. everywhere on the Windows platform. Probably not down in the kernel much, but the whole layer above the kernel is all COM, 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 COM. And most of the time you can ignore it. Doesn't matter that it's COM or whatever it is. But every now and then you'll run up against some problems if you're developing on a Windows platform, and you really have to understand what the COM technology is in order to get a handle on that problem. So I think it's important if you're going to develop on Windows platforms for you to understand COM. And you'll understand enough by the time we get done with Project One and the discussions we're going to have about it, that you'll be reasonably comfortable. I've had a number of students send me emails, and say, hey, I got a job at Microsoft, and guess what? I'm developing COM. Okay, so the beginning part of the, I've got several lectures that are associated with Linux and Bash and stuff. I probably, last year, for example, just about everybody felt comfortable with Linux, and I didn't wind up talking about it much. How many people have developed on Linux now? How many people have not developed on Linux? Okay, I will talk some then, but I probably won't spend as much time as the syllabus says we're going to spend with Linux. I'll survey the tools and stuff, a little bit, and the environment. I've written some Linux stuff, and we can take a look at that a little bit, and so on. But as soon as that's done, we're going to start talking about COM for a while. And then eventually there's some student presentations will start. Now, I think the student presentations are going to start before I've scheduled it here, simply by the number of people that are here in the room. Because the presentations, it isn't like 10 minutes of presentation, so it's significantly more than that. So I think we're going to need more time than I've allocated. When I did this syllabus structure, I didn't have as many people in the class. I didn't have as many people in the class last year as I do this year, and we started earlier with the student presentation. So I'm sure we will. Once, by the end of next week, when, the class size is pretty stable, I'll revise the syllabus so that the schedule, so you'll really understand, you'll know when the presentation will start. I'm going to ask you by the end of next week to pick a final project. I'm going to go over the list today. Most of today is going to be talking about projects. And I'm going to ask you to decide if you're going to work on it individually or collaborate with other students. At most, teams can't be any bigger than 3. It can be 1, 2, or 3. And by the end of next week, I'd like you to tell me how many people are going to be on your team, 1, 2, or 3, and which project you're going to do. The second thing isn't cast in concrete. I don't have any big heartburn about somebody starting off saying, okay, I'm going to work on this project, and then changing their mind. Oh, gee, I looked at this other thing and it looks really interesting. Can I switch? And the answer will almost certainly be yes. But mostly for my scheduling, we'll want to do that. So we're going to talk a little bit about Linux. We'll start starting on Thursday. We'll talk a little bit about Linux and some of the tools that we'll use. And fairly quickly, we'll get into COM and talk about COM. And then we'll begin working on the final presentations. So let's look at the projects. By the way, these project links, the Project One links here are incorrect, but on all the lecture pages they're correct. So there is a individual Project One and then final project. So let's take a look at the individual Project One. Again, no exams in the course. You're graded on project one submission and on your presentations and the content for the final project, what you do on the final. And and the final project is by far the biggest part of your grade. But for project one, the model here is that we're going to build components. We're going to build a COM component that wraps some pretty simple stuff. The functional content in this project intentionally is really simple so that you can focus on COM. The focus isn't on how do I implement that requirement, it'll be almost obvious. The focus is on how do I wrap that functionality in COM, turn it into a COM object. And this project will require you to build two COM components, one using another, so a client software uses one COM component, and that COM component uses another COM component, and that causes some technical stuff that you need to understand to make that work. But COM only exists on the Windows platform, doesn't exist on Linux. There was, for a while, some effort to port COM to Unix. A couple of my former students went to work for, it was a company in Connecticut, the Bristol Technology, that was porting COM to Unix. But Bristol and Microsoft got into a legal battle, some really hard feelings, and so that was abandoned. And as far as I know, COM technology doesn't exist on any platform other than Windows. But if you're going to be a professional developer, chances are pretty good you're going to spend at least part of your career developing on Windows, and so I think COM is really important for you to know. So we're going to build we're going to create some fairly simple functionality in the text search facility, and we're going to wrap it in a couple of COM objects, and then we're also going to build something quite similar on Linux. Linux doesn't have COM, but we're going to build components. A component basically means there's an interface and an object factory and some lifetime management. Now, COM does it in a very particular way, but so we're going to do that on both Linux and Windows. Windows for COM and Linux. Now, on the Linux platform, last year I recommended that people use Eclipse or NetBeans, and that's okay if you want to. But I discovered that some of, both NetBeans and Eclipse, if you have an older version, you build on an older version, the projects don't work and don't convert on the newer versions, and it was a real pain for me. So what I'm going to ask you to do is, however you build them, you submit the project with a make file. It will allow me just to build it using your, new make, and so I don't have to, convert your project, your Eclipse project to a different version. So, but you can use either one, and I'll tell you enough about. Most of you probably already know, but the few that haven't worked on Linux, how do I get an IDE on Linux? I'm going to suggest, I'm going to probably myself use, there's a code editor called Atom, built out of a JavaScript framework. I'm going to talk about that a little bit today in another context. But I may use that with Make. That doesn't hook to a compiler. There's also VS Studio, Visual Studio Code, but it isn't Visual Studio. It's built, I think, using a JavaScript framework called Electron, and with MongoDB holding everything, all the properties and settings and stuff, and projects and stuff. And you can hook that up to GCC and client. So it really works like an IDE. And it's pretty nice. I downloaded it. I didn't get it to successfully hook up to GCC. I only, I spent 20 minutes trying to hook it up. Okay, so that wasn't enough time. And so I'll let one of you figure out how to do it, show me how to do it. Okay, but you know, it looked pretty nice. VS Code looked pretty nice, and that runs on Linux and Macs, wherever you want to run it. So project one. Now we won't know enough COM for a while to complete this program. So I have a due date of March 20th. What I'd recommend is that you create the C++ guts, the simple part, that's the text search thing, and wrap it up into a component and get it going on Linux. And then as you're beginning to think about the final project, you know, you'll have heard as we get close to the presentation for the final project, you'll hear enough about COM to go ahead and proceed and develop the project. Okay. So did you do any COM programming when you were at Microsoft?
I was working on firmware.
But, you know, and so that's why the due date is late as it is, simply because it's going to take us a while to get where you know enough COM to do the Windows part. The more interesting thing to me are the final projects. So, you know, you're welcome to take a look and ask questions next time about this if you want. So, final projects. So, so the intent of the final project is to allow you to, you know, work on some cross-platform stuff or cross-technology. A lot of the projects involve that. And play with some stuff that you haven't done before. If you haven't used Node.js, for example, that's a really interesting technology that we'll talk about a little bit today. And also, it's a real nice opportunity to work on a portfolio project for your interviewing. So just something nice to tuck under your arm, you know, when you walk into an interview, or something interesting to talk about on a resume to attract offers to interview. You will make 3 presentations. The first one is a technology overview. So once you've picked a project, you'll start looking at the technology a little bit, and you will get up and do a tutorial for the class on that technology. And what that means really depends on the project that you've used, that you've selected. So I'll come back to that question at the end of this today, and we'll readdress that. But the intent is that it's a tutorial, but also describes your project, what you're going to do with it. So the issue isn't just learning this technology, it's doing something useful with it. And so I want you to specify, here's the project that I want to work on. And I got a bunch of suggestions, a big long list here for that. Again, two things about that. One is, I would like you to be aggressive in your project goals. I would rather see you aspire to a really great project and fall short than do a very modest project and succeed. Now, you have to succeed in part, you have to do something useful in part, but if you don't, you know, if you don't get all the bells and whistles, you know, done the way you'd like, that's fine. I want you to be aggressive in trying to do something challenging and really interesting. So the first will describe your project and the technology, sort of a walkthrough of the technology. One of the reasons why fairly early I want to know what project you're working on is there may be several different groups working on essentially the same project, kind of project, so the technology descriptions would be overlapping. And so what I'd like to do is then try to work with you so to get one team to kind of focus on this part of the technology, another team focus on this part, another on this part. And so what we're doing is not only are you learning the tech, but you're instructing the rest of the class on that technology. The second presentation are probing examples. So the idea is we have a project and a technology, one or more technologies we want to use for the project, and now we're testing the technology, writing probing examples, code examples, little test examples that move us, that let you explore what the technology really can do, and at the same time moves you closer to your final project. And the last presentation will be your final project presentation. And they are long. I'm sure we're going to wind up scheduling them a day or two after classes are done this spring. What we do is we just all day long sit here in this room and do presentations all day long. So you can take as long as you want. And typically I'll do that on a Saturday and a Sunday. And so by the end of the day on Sunday, we're all done. But everybody has plenty of time to talk about their final project. So that's the mental model. Okay. So let's talk about some technology. So obviously, you want to know a little bit about C++ and C#. Some of the technologies are cross-platform, as we'll see in a couple of minutes. But a lot of them involve JavaScript frameworks. A significant number of them involve JavaScript. So there's a lot going on in the JavaScript arena right now. ECMA 6 is out. JavaScript now has classes. And there's a whole bunch of stuff that's associated with it, like web workers and WebRTC and tons of stuff. Node.js is a JavaScript framework. Electron is a JavaScript framework. Lots of JavaScript frameworks. And they are becoming very, very popular. Lots of work going on. So it makes sense to get your arms pretty carefully around JavaScript. And it turns out that JavaScript is weird, quirky, easy to do easy stuff, but as soon as you start doing anything at all tricky, it's really easy to shoot yourself in the foot. Okay, so we'll talk about that a little bit today. For example, I've got a little link here on these. These are links to get you going, but I got a little link here on this is how the JavaScript execution engine works. So if I'm downloading a page, this is the way a browser treats JavaScript. It's not the way Node.js treats it, although the Node.js environment is very like this, but it's slightly different. But, if I have JavaScript in the body, a function context is pushed as that's being parsed, pushed onto the execution stack. Otherwise, events that are triggered in the HTML DOM, the onload event and a button click event and all those, put an entry in this message queue. It's again a function context in this message queue, and when this stack is empty, then events are pushed from the event queue onto the execution stack. So typically, this is empty. We pull a function, JavaScript function, and put it on this execution stack. And that function may well push down other JavaScript functions so we get more on the stack. And we don't go handling any more events until we've pulled everything out of this execution stack, and then we start pushing events on again. So typically, all the events come through events on a page, that way up into this event stack. Very, very event-oriented. Single-threaded, it appears like it's multi-threaded, but it's single-threaded. And Node works this way. Node works just like this. where stuff comes from. There isn't any stuff coming from a body on the page into Node, but a little later on, I'll talk a little bit about the Node execution environment. Not today, but. So there's quite a bit to look at. I've got a link here to the ECMA 6. This is a nice little summary of stuff. And you'll find that MDM stands for the Mozilla Developer Network. Excellent description of web technologies. Excellent. A really nice description of JavaScript, really nice description of cascading style sheets, really nice description of HTML5. And we may wind up in some of our projects using all that. Yeah, so I'm just talking about the technologies now. When we get to the project list, we'll see a little bit of that. Python is kind of interesting. A lot of QA organizations use Python as glue. You can run other programs with Python. So you write a little script that runs a whole bunch of programs, okay? So it's a really flexible way of getting bits of functionality to work on what you want it to work on in the order that you want it to work on. Okay? So that might be, that's a technology stack that you could well apply to some of the projects we're going to talk about. HTTP, an awful lot of the projects involve in one way or another HTTP messaging. So, and this HTTP made really easy, and I wrote a little HTTP client server. So there's a project, Tiny HTTP web server and client, and I wrote a prototype for that. And I'll run it probably when we talk about that project. I just take a minute just to show you what happens. But you need to understand that technology for a lot of these projects because there's a lot that's distributed processing going on and a lot of HTTP communication back and forth. So Node.js is essentially a framework for dispatching HTTP messages. That's really what it is. Okay? It's a JavaScript mechanism to dispatch HTTP messages. HTML5 we'll find is interesting. One of the projects specifically uses that, so there's some links for that. Web workers are interesting. So now, as of about the time that HTML5 came out, web workers were introduced. They were kind of associated with HTML5, but they're not really part of the HTML5 spec. But they are starting threads in a JavaScript environment, which does not these days mean a browser. It may mean a browser, but it might mean a server running Node.js, for example. So Node.js, I'll talk about that in just a minute. So but web workers is the way of starting up threads that will run in a JavaScript environment. Now the interesting thing is in a browser, a child thread is not allowed to interact with the DOM because the DOM isn't locked. The way the eventing works, it cannot block, really serious to block. And so you don't want to have locking because stuff will block and mess up the eventing mechanisms. And so only one thread is allowed to interact with the DOM. But what these other threads are used for is, for example, to do AJAX or to invoke web services at another, cross-site web service. Another technology that's interesting are the WRTC, WebRTC, and SignalR. So this is web standards, and this is ASP.NET's version of essentially the same thing, I think. What it basically does is when a client contacts a web server, it's a way of keeping the connection open so that the web server at some later time can push stuff back to that client. There was a framework called Comet that used to do that by polling, but now WebRTC and SignalR are all about keeping that connection alive and then pushing stuff back when the server is ready to do that. So Node.js is a JavaScript framework, and basically here's Node.js. The way it started was a guy by the name of Ryan Dahl, and I think there were some other people involved, took the Chrome engine, V8 engine, which Google published. Here's the engine inside Chrome, and they took it and hosted it, wrote the code to host it in an executable image instead of in a browser. That's what Node is. Node is that JavaScript engine running in an executable, so it can run on a server instead of in a browser. And a lot of people are doing exactly that. They're running Node in a server, and the mean stack uses Node and Express and some other JavaScript stuff to, so here is JavaScript running. That's JavaScript code. All the server operations are written in JavaScript, not just code that's going to run on the browser. Microsoft is running Node. Google's running Node. Almost everybody at the site is running Node these days. Pretty interesting. Express is a JavaScript framework that is essentially a Node module you can load down on Node, and it turns Node is basically an HTTP dispatching mechanism, and this Express adds some web. It turns that dispatching mechanism into a full-blown web server. Serve up pages and scripts and styles and stuff. AngularJS is a JavaScript framework supporting client-side mono-view controller. So what it does is it structures JavaScript that's running in a browser, providing a much more structured way than we normally do. React.js is a event-driven framework whose intent is it'll run in a browser, but it's event-driven, and what it wants to do is the same kinds of things that Ajax does. Ajax goes out and instead of downloading a page, it makes a call, it gets a string or something, and injects it into a DOM element to change the DOM element. It gets rendered without loading down a whole new page. Well, React does that pervasively. It's a way of setting up so it's a single page, but all kinds of things happen on that page because React is managing that. MongoDB is a NoSQL database. In OOD last year, we did a NoSQL database. We're doing a very similar one again this year. The requirements are a little different, but and the mean stack is basically a combination of some of these. We'll talk about that a little bit. Firebase is a platform. It's not an open source. It's a proprietary platform, but we can use it. You can get a developer access for free that uses Firebase. Basically, it's a chatting, messaging, and authorization platform that I'm told, I haven't tried to use it, but I'm told it's very effective, really easy to use, and do some interesting stuff. So there's a payment. I'm sure it uses Google Wallet. I don't know whether Google Wallet will survive. A lot of the Google competitors are trying to fix it up so that Google Wallet won't work. I don't know the details of what's going on, but I know there's a lot of stuff going on. Electron.js is a JavaScript framework for building desktop applications. And I'm sure it's based on Node. Pure node is in that mix, but it's designed to build things like GUIs, stuff like that on the desktop. And Atom.js, in fact, is a GUI that used Electron for its implementation. And here's what Atom looks like. So, here's an Atom editor, and that was this guy is one of the guys that you might use on Linux instead of using Eclipse or NetBeans to use this. This is just an editor, no compiling. But if you use Make and this editor, that's a nice combination. You can do stuff just about as quickly as you would with an IDE. Okay. Cinder is a C++ library that wraps OpenGL to do graphic stuff. So gallery. Here's some of the stuff that people have been doing with Cinder. It's used professionally by media people to do interesting things. About 3 years ago, I think it was, a team in this course used Cinder to do a really interesting project. They were mining, social media mining, and they were, presenting interesting stuff. So that's a possibility. OpenGL is very capable graphics environment, C++-driven graphics environment, but is it big? It's got, the interface is huge. Okay, so it would take you forever. And Cinder, reportedly, is pretty easy to use. It hides a lot of that low-level OpenGL stuff. So that's a possibility. Mean and MERN stack. So Mean stands for Mongo, Express, Angular, and Node, and MERN just substitutes React for Angular, and it adds a couple of other, Redo and Webpack and stuff. So there's a project, one of the projects directly involves using either one of those stacks to do something I think is kind of interesting. Container technology might be useful in some of these projects. A container basically is a standalone executable that packages up everything necessary for that executable. In other words, if you you have a bunch of properties, you have some DLLs, from an environment. So you have a runtime, for example, the .NET runtime. You could build a container that contained that .NET runtime, and so if the runtime changed, next year, it wouldn't break. The container will still run just fine, thank you, because it has the current runtime packaged up. So containers do that, and a lot of interest in containers as a deployment mechanism. Another technology is kind of interesting. Alexa services. You can access some of Alexa's capability, voice capability, and stuff like that, and skills capability in your own programs. This is not a free service, but there is a free developer window. You can subscribe and use it a little bit and do some cool stuff. So, blockchain is another kind of interesting thing. Blockchain is a distributed, so it's like a distributed hash table that's persistent and encrypted. So you can record a transaction, and it isn't saved one place, it's saved many places. So if somebody changed it, you would know immediately, you know. So it's encrypted, and if somebody is in there monkeying around with it, it becomes public knowledge immediately that something fishy happened. And that blockchain framework is what's used to build Bitcoin and Ethereum or whatever it is, you know, that sort of stuff. So that could be an interesting thing to poke out a little bit. So we're talking about these are technologies that interest me. It's just my interest list, okay? So things I like to look at over the summer or when I retire or whatever. Now let's look at a project list. So the project list starts out with, and you can get to any of them with these links, a tiny HTTP client and server. So let me give you a little bit of background here. I'm really interested in cross-platform and cross-technology programs. So let's think about platforms. So here's Windows, and there's Linux, for example. I'd like to have a common core of code that runs without change in either environment. But that means that anytime it's using platform services, there has to be some library stuff down here on those platforms. So A prime, B prime, and B. B and B prime have the same interface. A and A prime have the same interface. So the common code is just making the same calls no matter which platform they're in, but the contents of A prime and B prime are different from the contents of A and B because they're both using, so A and B are using the Linux API to implement that interface, and A prime and B prime are using the Windows API to implement that interface. And I've already done some of that. You know, you may have seen, you will use in your project one, I have a file system Windows and a file system Linux, and it works exactly that way. C++, standard libraries don't provide a directory management stuff. Some of that is coming, and I don't like it much, the way they built it, okay? But what I did was I looked at the .NET system.io namespace. I love it, you know, the directory class, the path class, the file info class, they're easy to use, sensible, you can understand them immediately. My code stole that design. I just stole their design, okay? It's really close. It works really close to what the .NET stuff does. And I implemented it for both Windows and Linux, doing exactly this. Now, the other thing that happens, you say, okay, so yeah, we're getting so that we can make code work on both platforms. How about GUI? So on Windows, we have this really nice WPF. What's there on Linux? And the answer is not much. There's Java FX. Has anybody here used Java FX? Maybe I can con one of you in your projects to use Java FX, because I want to know a little bit about it. I want to know how it works, okay? So if one of you uses Java FX in your technology presentation, you can instruct me, okay? So I'm told that a WinForms to WPF is like swing to Java FX. That's what I'm told. So it'd be interesting to know. But anyway, there isn't that much on the Linux if you're programming in C++ or whatever, and there isn't that much on Windows. C++ doesn't have any GUI. Nothing in the standard library supports GUI stuff, but it's really easy to build a C# interface and interoperate with C++. Really easy. Okay, but the same kind of thing doesn't happen on Linux. So how do we build a cross-platform GUI? And my model is we take Chrome that runs on both those platforms, or runs on just about all platforms. And down in our application, we make a tiny HTTP server. And here, we do the same thing as C++, okay? Tiny HTTP server written on Linux, okay? Or we could use, if we're using, well, let's leave it at that. So tiny HTTP server, and now the way this works is the tiny HTTP server serves up one HTML5 page that represents your interface. And then every time you click a button, it does an AJAX call. It's not asking for a new page, it's asking for something to happen on the server that may send you back a string or JSON or XML or nothing, okay? But something happens on the so there is a GET request. There's a GET request that gets the interface, and then after that, it's just a whole series of AJAX calls. Click a button, pull a slider or whatever, okay? And just AJAX calls. So all of a sudden, we have a GUI that is structured using markup, HTML5. It isn't XAML, but it's HTML5 markup. And we have JavaScript eventing instead of C# eventing. Same, but it's the same model. Now we have a GUI that works on either platform. And you absolutely can do it. I've had 2 groups over the past 3 or 4 years implement that. They really work. So that model, cross-platform development, piece of cake. Once we have those pieces in place. Yeah.
I didn't get the part. Why are we actually using Chrome here?
So I want a nice GUI interface. It's easy for me in Windows to build it with WPF with a little bit of managed C++ to talk to my C++ code. So this is all C++ code. Okay. These are all C++. C++, okay? On Linux, how are you going to build a GUI? You can use Qt, you can use KDE, you can use WX widgets, and they're all clunky, old-fashioned, don't do much, not very interesting, hard to use. Every one of them. Okay? Every one of them. I've tried them all. Okay? I haven't tried them all, but I've tried a lot of them. So this is taking you into the WPF style. Markup and eventing. Okay, so now, but also this tiny HTTP client server, now you don't have to serve up web pages. Now you can have your distributed system as a communication channel, okay? So, now you can use this HTTP messaging. Understand that HTTP, the model has always been client server. You send an HTTP request and you wait synchronously for a reply. That's really what HTTP was designed to do. But there's no reason to use it that you can absolutely use it in a one-way, just like the message passing code that you've all written in my classes, we can do the same thing, okay, using HTTP. So not only will it work for cross-platform development, but it'll work really nicely to enable communication between parts of a distributed system. And also, now I could have a Java application running on Linux using the Apache client, HTTP client and server, that talks to my C++ application running on Windows that uses the tiny HTTP client server. Yeah. Cross technology communication, okay? One interesting application might be I'm running a virtual machine and I want to test it. So I'm running Java in a virtual machine with Linux, and now I want to test it using my C++ test framework on the host. Well, virtual machines allow you to do HTTP messaging between the client and the host, the guest and the host. Okay, all of a sudden now I can have a test harness that works across those virtual machines. Or I can have two virtual machines intercommunicate, running different, one Linux Java and the other one Windows C++. Cool. So lots of stuff kind of opens up, lots of possibilities. Okay, so enough of that. By the way, I did do a little prototype in case you're a little worried about that. Here's my HTTP. So here, I click this. I'm just sending, messages back and forth. Let's pull up this guy. Here's my local host. Okay. Click, 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 click. What I'm doing is I'm sending a request, and my HTTP server is just forming up a little bit of HTML, but changing this message just so you can see that it's actually sending a message, back and forth. So, and all of those, every time I accept the request, my server accepts the request and then sends back a reply, it shuts down, and then it, reconnects. That's the way most browsers work most of the time. Nowadays there's some keep alive stuff that's going on. But anyway, it isn't that hard to do. And is this really tiny? My goal was to write a tiny web server in about 1,000 lines of code. Well, where'd you go, 775? Here's SU, 775, code, project, final project, project final help. I got to remember where I put it. Project final help spring 18. So here's this code, and I ran my analyzer on it. And here's the line count. So my code analyzer has a mode where it'll give you line counts. So I didn't get close to my 1,000 lines of code, but 1,000 of those are the socket library. Not really fair to count that against the, my mental model was I wasn't counting that. And the other interesting thing is that the messaging class is by far the next biggest part. I put a lot of the functionality in constructing and parsing HTTP messages. So the clients and servers are really small. Here's my server. Now, the server consists of HTTP server and, there's a couple of classes here, but, these are small. Most of the functionality was in the better hurry up. So anyway, if you're tempted to do that project, but you say, gee, I'm a little worried about implementing a web server, okay? The prototype there is there to get you going, so that you don't not do it just because you're afraid of it. Cross-platform GUI using Chrome and TinyHTTP. There's a project to develop cross-platform libraries, so there's a bunch of stuff. You know, there's a fair amount that's implemented. We don't need to implement threads because now C++ 11 has a thread library. We don't need to do that. But a process class, for example, there's a bunch of things that would make sense. Capability to add a full-up messaging, you know, communication channel library, you know, building on the HTTP messaging, you know. If you're interested in that, we can talk about that a little bit. So file system really already exists. Sockets, I have a sockets for Windows, but I haven't ported it to Linux. Now, that socket code came from Linux originally. Because, well, my original socket package did. I just wrote it. But then when I wanted to implement IP6 capability in my socket package, IP6 is kind of a mess. Okay? It's complicated, widgy little data structures that run all over the place. And so I went to there's a link somewhere, BG's guide. I went to a source that had implemented IP6 on Linux, and I just ported that to Windows and then refactored it into, I have a socket, base socket class and a socket listener class and a socket connector class that derived from socket. And that original code wasn't written that way. It wasn't using classes at all. It was written in a C style. But it should be fairly easy to port back. There wasn't much to it. There isn't that much, you know, you're interacting with a Berkeley Sockets API and a few, you know, just a couple of, I don't think there's much at all to port that to back to Linux. And so, you know, there's a bunch of things. If you're interested, the file system stuff, there is a experimental version of a file system that I don't like much. It's written in the STL style and uses iterators. Its interface is an iterator interface, which for linear data structures works pretty nicely. But here we have directories and we have files, and it's kind of painful to use. It's that you know, what will become the standard. It was modeled after ASIO Boost ASIO. And so, but it would be interesting. One possibility would be to take my implementation of file system Windows and throw out the guts of it and use the experimental, you know, what will become the standard file system for C++, and implement this nice .NET interface around it. Okay, be an interesting, bunch of interesting things to do. Sockets library needs to be ported to Linux. Process, I don't really have a good process library. It'd be really nice to have a nice process library. And the process, .NET has a really nice process facility, but standard C++ doesn't. I don't in my libraries. And Linux management of processes is a little different than Windows management of processes. The interface is quite different. So, yeah, there's a bunch of stuff to do. Doesn't mean that one would have to do every one of the, you know, all of that. But okay. Test harness using a process pool. So we built in SMA in C# a build server using a process pool, and this was simply implements a test harness using a process pool. So. Repository using pluggable components. Most of you guys, you understand, you know, basically what those are if you've taken classes with me before. These two are closely related. REST web services is program components and microservices. So the idea of these is instead of providing a bunch of static libraries or dynamic linked libraries you're going to load, you provide operating system services or something like them. You provide running services that your programs interact with to build a lot of their functionality. And one reason that's interesting is, for sure, there's a whole bunch of AI services that are coming, like the Alexa service. That's coming. This is an AI wave that's going to wash over all of us. You know it's coming. So I think we'll probably build a lot of programs using that model, the Microsoft, that microservices model. And the idea is simply you got these active things that are running all the time, and you build a program by gluing them together. So there's two ways to do it. One is to use REST, which is a web API, and the other one is the microservices. This idea is simply we'll use the tiny HTTP client servers to communicate back and forth between those running services. Okay, and so we just glue our programs together out of those. A lot of interesting microservices these days. Virtual display system. About 5 or 6 years ago, we did a software modeling analysis project. That was a architectural document. We just developed the architecture for a virtual display system. And the model was there. It's a display that covers this whole wall. And we're going to use that. So here we are in Syracuse, and we're going to use that display to interact with a team in Mumbai and another team in Beijing. And so we want to put up webcam windows. We want to put up documents. We want to put up digital whiteboard that we can, just draw on and send message back and forth. And so this virtual display system was a mechanism for managing the layout, runtime layout of those things. So people could pull stuff around where, I want the document here, and I want my webcam views there. Just lay them out. That was the idea. That was the model. So this program, this project says, let's work on the rendering for that sort of thing. We don't have these big, huge displays, but, if you have a 50-inch TV, high-definition TV sitting on your desk, and that's what you're using for a display, this summer I'm buying one and putting it on my desk for exactly that purpose. You got a lot of real estate, and now that kind of rendering stuff starts to get really interesting. So instead of letting Windows do its thing, rendering stuff, you get to exert your will about how you want things done. Virtual repository server. The model here is that I have, in some sort of federation, I have a bunch of servers, maybe a test harness or a repository or whatever, that are serving my project, and I'm a team lead, and I want one of those on my desk for my team. I want my team to share a repository and a test harness. So for the project, the rules about what can go in the repository and what can be run on the test harness are fairly rigid. But as a team lead, I want a whole lot more flexibility. I want to throw out most of those rules and just a few of us just interacting together in a very flexible way. And so I want to be able to say, okay, I want that repository on my desk with this part of its contents. So what that means is, on your desk, you simply have a little receiver that knows how to download parts and assemble them. And most of it is the server has a clone that's just making calls into your receiver, dropping the parts and the content that you asked for into that server on your desk. That's the virtual server. It could be a repository, it could be anything else. Node.js, there's a lot of interesting stuff you can do with Node. This one is a remote data acquisition and visualization using Node.js. So the model here is that I've got a bunch of little sensors. Somebody did a project like this last year. And their project was an app to provide parking information. So, is the parking lot I'm heading for full? If it's empty, show me where the empty spots are. So the parking lot has a bunch of sensors around it and is communicating using Node to the cloud, and the cloud, you're getting, the app is interacting with the cloud, pulling that information down. But there's another case project that we're going to try to staff very shortly. The case project is a business in Ithaca that's building agricultural systems for farmers to use that automate loading of, you go in with a payloader and get so many shovelfuls of this and put it into that hopper, that kind of stuff. And so there's a bunch of sensors running, and it's got to be communication back and forth, and Node is a great way to do that. So that's the model of that project. We go until 4:50. So we get them. Cloud computing. So here, I talked about using open clouds, private clouds. I think it would be a whole lot better not to do that, but to do a project that involved AWS or Google Cloud or Azure. The reason for that is it appears to me that private clouds are kind of going downhill. There was a whole lot of interest about private clouds for a while, and it seems to be dissipating. So if you want something that will look interesting on a resume, private cloud probably is not the thing to do. But using Azure or AWS or something to do an interesting project might well. I haven't thought a whole lot about what the application might be. So some of these projects are fairly specific about what, some of these descriptions are fairly descriptive about what the project would be. But some of them are like this one. So you got cloud computing, go do something with it. Okay. So I don't mind, if somebody was interested in doing some cloud stuff, some Azure or AWS stuff, maybe you want to work for Amazon. And so I'm going to get some experience with AWS and put it on my resume. So, we could come up with an interesting application for that. Personal website using the mean stack or the MERN stack. The idea of this is that you're going to build a website that provides the story of you. So here I am with mom and pop, in my hometown, whatever it is, okay, in Gujarat or Punjab or wherever it is, okay. And here I am in my college with my buddies, and here I am in Syracuse, with my buddies, and here I am taking an exam or whatever, and here I am at Google, I work with my buddies, okay. So it's just, and so the story is a timeline of story blocks, and each story block is an image and some text, and a way of sequencing through it. That's the model for this website. This could be a story about you personally. It could be a story about the EECS department at Syracuse University. Could be a story about your hometown, whatever. But the model here is both that here is a non-traditional web application, something that's sequencing whose real purpose is to sequence through chapters in some history, and built with stack technology, mean stack, Mongo, Express, Angular, and Node.js, or MERN stack, replacing Angular with React. Yeah, thank you. So, and these days with HTML5, there's a lot of interesting stuff, media stuff you can do. HTML5 makes it easy to do media presentations and, manage color backgrounds, a lot of interesting stuff. A Visio style drawing tool, let me skip over that because we're getting a little short of time. GraphViz is a project near and dear to my heart. Here's the idea. We have a graph. Maybe these are software components. Maybe these are packages in the Linux kernel. And I don't know how we're packaged, let me guess, 3,468. Is that right? I don't know. That's not far from this, something like that. So, I want to represent them with a dependency graph because I want to understand. I want to understand that software. If I don't have a layout scheme, what happens is they just go random, and I got all kinds of crossing wires, and you can't make any sense out of it. It's just a maze of spaghetti. But what this does is this uses a physics model that says each one of these nodes has a repulsive force. Maybe a inverse square law repulsive force. Get them real close together and they push out very hard. But as soon as they start to get farther apart, the force goes weaker and weaker and weaker because it's 1 over the distance between them. The arcs are a spring that's linearly trying to pull them together. And so the physics, you start in any old configuration you want, and the physics makes it spread out. Now, it turns out you need a little bit of damping too. Damping is a force that's dependent on the velocity, how fast they're moving. If you don't have any damping, what you see is this stuff oscillates. Back and forth, back and forth, that's what the physics does. You don't have any damping in the system, it's like a pendulum, it keeps going. But a little bit of damping, and then voila. This was written in JavaScript. So now there's a whole bunch of interesting things. So suppose this was a description of software components. Suppose we did a little bit of analysis of each component, just a little bit of text and semantic analysis. So now we label this. Here's the name of the component, and if it's got, if it uses threads, we have a thread category, and if it uses sockets, we have a socket category, and if it uses GUI stuff, we have a GUI category. And so now all of a sudden we get some information about, without us ever really digging into it, we get some information about it. And now maybe we'll allow you to come in and edit. As you're learning about that Linux kernel, you start putting your own little annotations here about what those parts are, and all of a sudden you got a travelogue that helps you understand this big, complicated piece of software. So, so layout is a really interesting part of the problem. So graph visualization, software visualization. So this graph visualization is mostly focused on the layout part of the problem, and the software visualization is focused on the annotation and doing some analysis of the parts and stuff like that. So it combines those two ideas. I combined those two ideas. Here's another project that would be kind of interesting: an Audible logger. So a lot of you have used one or another of the loggers I've written. So you're writing out message, blah, 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 blah. And you want to put stuff out for debugging purposes or to convince the TAs that you implement the requirements. Wouldn't it be cool if instead of that cluster of huge 20 pages of output, it started talking to you? I am now starting up the server. I am, whatever. I just wrote, speech API. Kind of cool. And you can have debug mode and a demo mode, and the demo mode talk to you, and the debug mode put out text. Something like that. That's the model of that. Using web apps on the desktop. So this is just a half-baked idea. I was talking about when I was writing up the Audible Logger, I did a little bit of searching to see what kinds of library support was available. Microsoft in .NET has encapsulated speech API. It works pretty well. You know, if you took design, how many of you took design patterns last time? So you saw my strategy pattern, you know, airplane, Fawcett Airlines taking off, and you know, that was using the Microsoft Speech API. You can use that same. But now, in looking at it, it looks like almost everything is moving to the web. All this, hardly anybody is doing desktop libraries anymore. It's all going to the web. Alexa, you know, all of the Microsoft Speech APIs are moving to the web. All the recent stuff appears to be. So now the question is, suppose I want to use that stuff. Suppose I want to build an Audible Logger, but I want to use Alexa speech, text speech. Or I want to use some of Alexa's intelligence. Maybe I want to build a software assistant, and I want to use some of Alexa's intelligence. So how do I do that? I want this to be a desktop application, but that's web. So, you know, clearly what I want to do is I want to use a web service API. You know, there's an Alexa API, a RESTful API. So basically what you'd be doing is using the tiny web server to talk to that service, and so you can use that service on your desktop. In a desktop application. Another possibility would be to use Node, because Node is, you know, with Express on it is a HTTP. You know, you can consume web service just fine with Node, and even easier with Node and Express. The issue there is Node can use C++ code, but C++ code can't use Node. I don't think it's practical. I thought about it a little bit. I don't see a practical way to do it. And I did some searching on the web and nothing. But what you could do is in your application have a tiny HTTP server that talks to Node, and Node consumes the web service and maybe consumes it, you know. Interesting idea. Directory synchronization using the Go language, or the new language of choice, whatever you want to use. There's a whole bunch of them. So Rust is a language that Mozilla is developing. It's supposed to be a system programming language. Go is interesting. Go is like C on steroids. I have a love-hate relationship with Go. Go has some really interesting parts, but there's some stuff that it doesn't have classes, and it doesn't have templates. Give me a break, Go. You know, do I want to handcraft every data structure, you know, a data structure every different type I want to use? I don't want to do that. Okay, so, but, you know, there's Go, there's Rust, there's Scala, a bunch of different languages, you know. So the model here is that we're just going to try doing something fairly straightforward that would be straightforward in C++ or C#, and use one of those other languages. So for example, you might say, I want to use Go, or I want to use Rust. How do I communicate? How do I get a graphics? How do I get an interface, usable interface with that? Well, since Rust was developed by Mozilla, almost certainly it has a web interface, okay? And you can use it. I don't know whether Go does. I would be surprised if it didn't. So that's the model for that project. We're just about out of time. I've covered all there's one more project that two guys worked on last year, and I wrote it up just because they were interested in it. And I say it's too large for distributed project. This is basically a study about a federation, like the ones that we have talked about in SMA architecture projects and stuff. And they were interested in using containers and DevOps to build these kind of things. And the question was, how do you manage projects that are